back when OpenAI started, so OpenAI said, make the AI open for everyone, like the word said, OpenAI.
Yeah.
And when Huggingface came into the picture, he said, we'll make a very good chatbot for us. And now
that's right.
they're totally Hey everyone, welcome back to the channel. So today we have a very special guest, Louis. So a brief introduction about him. He has a rich experience, I'll tell you. So he has a PhD in theoretical and mathematical physics. That's what I got from LinkedIn. He has a postdoc in theoretical particle physics. And then he wanted to switch gears and he's working as a machine learning engineer. And he has a rich experience, like he has been an ML engineer, data scientist, lecturer, and top of that, he has been a startup mentor as well. So hey, Louis, how are you and how's life going?
Hey, Prince. Thank you very much for the introduction and thanks for inviting me on your podcast. It's a real pleasure to be here.
Yeah, it's a great pleasure for us as well. So you being here means a lot to our audience. And so in due course of time, we really look forward to hearing your thoughts and views on certain topics. And I hope this will benefit most of our audience.
Great. Let's dive in.
Okay, so even though I gave a bit of introduction, so I would like to hear a bit from you as well. So it would be very great, like if you can tell us about a bit more on your background and how you got into machine learning, like given your background in postdoc in physics, your ML journey, you can share.
Yeah, sure. It's not a very conventional path. So when I was studying in my undergrad, I had to take a course in computational physics, which was in Fortran 95, and this scared the hell out of me. And I didn't touch a computer after that for like 5 years. And I ended up kind of pursuing a very kind of mathematical branch of physics where it's very much pen and paper type of calculations and more like kind of theorem proving and things like this. And towards the end of my postdoc in Switzerland, one of my kind of colleagues, he said, hey, come check out this program I wrote. And at the time, many people at the Large Hadron Collider at CERN, they were interested in trying to find kind of signals of new physics beyond the standard model that we currently have to describe the subatomic interactions. And one way you try to do that is you look at like the collisions of protons in the collider, and then they create kind of very distinctive patterns on the kind of cylindrical detector. And what physicists had worked on for many decades was to come up with kind of algorithms that would allow you to distinguish different types of particles in the detector. And then this would give you a way of figuring out what is your signal and what is your background. And what my friend had done was basically train a neural net to do exactly that kind of work. So how to essentially discriminate basically different types of images that would give the signal background ratio. And it was like 100 lines of code in TensorFlow 1, I think. So this is like, the ancient days before PyTorch. And I was kind of shocked because I had like looked at these problems before, and I was like, okay, if an algorithm can do this at an accuracy that is, pretty competitive with a few decades of physics, I should probably pay attention. And so I kind of reluctantly said, okay, I should learn how to code. And so I taught myself Python, got TensorFlow 1, and just started playing around, originally with Kaggle. And so I did a competition with a friend on predicting like the Russian housing market. It's this old kind of, the old days where Kaggle competitions were kind of tabular competitions. And I kind of got addicted to this kind of process of taking data sets and then trying to understand them and then training models to sort of make the predictions. And since I was coming to the end of my postdoc, I had a kind of choice to make, which was to continue in academia pursuing particle physics or to do a kind of hard pivot into industry. And essentially through a bit of random chance, I joined a young startup in Switzerland, and they took me on with like almost zero experience in ML. And they said, okay, you're a physicist, you'll probably figure it out. And that kind of started the journey into the field. So it was kind of like something I never would have predicted when I was doing my physics studies. But I'm quite happy I made the change. I think it was, given all the current situation with LLMs, it turned out to work out quite well.
Whoa, that's very inspiring. I mean, yeah, no one would have thought, like, being from physics background, all of a sudden you are into, and now you're working on LLMs, right? Hugging Face is de facto. I think everyone in our company or anywhere in the world, they just go go into Hugging Face and they start doing everything in whatever they think in generative AI. Okay, great. This was interesting. So, I mean, now given the background you have, right, and now the work you are doing, how you can say, how difficult was it to like leave that background, because you have spent a lot of time, right from bachelor's and then moved to, how difficult was it, and is that experience still helping you here in any sort of?
Yeah. That's a really great question. So, and as you say, right, I spent almost 10 years doing theoretical physics and then did a kind of big switch into ML. And I think the change was hard at the start for a few reasons. The first one is that in academia, you're used to working on long timelines. So typically your research projects will take 6 months to years. Some of the problems are just that hard. And when I first joined this startup, the deadlines were like a week or less. So big culture shock is adapting to essentially trying to ship things as frequently as you can. And I think it's a great skill to learn to get used to just being productive. And the other one that I think was quite different is that I had been used to doing a lot of mathematics, and modern machine learning is very much engineering. I feel like it's very much an engineering discipline at the moment, and so much of that mathematics is not really useful that I learned. But what I did find useful was that trying to learn deep learning, for example, was relatively easy to pick up, because a lot of the sort of underlying math is more or less like linear algebra and a bit of optimization theory. And so you have a little bit of a head start on that side of things. And then the other one that was hard was definitely programming. So again, someone who had not really programmed much, and then trying to learn Python and then actually use it in the real world. I actually had a pretty good mentor in the first company I worked at, and he was this incredible engineer who could program in like 7 languages very fluently. And he sat down with me. I remember in like the first few weeks, he was like, "Okay, Lewis is kind of having a bit of trouble here." So we really pair programmed for a couple of weeks. He sat down with me, and the thing was, I had to write Java code. So this was like basically code that was going into production, essentially doing like stream processing, where you have kind of real-time data that you need to kind of aggregate very quickly. And he walked me through kind of like not how the language works per se, but how the code base worked. And I think that kind of pair programming was a really important learning experience to kind of quickly get up to speed and then, make progress.
Whoa, that's awesome, right? So it was a struggle a bit, then you finally settled down, and now you're doing great, right? In Hugging Face right now, all you do is programming, or do you have other responsibilities as well?
Yeah, so I think at Hugging Face, like most of us have pretty broad roles. And so when I joined, I was working kind of at the interface of the open source team and around topics of education. And so sort of one of the passions that I've always had is trying to sort of explain complicated things as simple as possible. And so in those roles, there was a mix of programming, but also then developing content. And we built a course together with other members of the team about the Transformers library. And I would say today, since I've switched gears to be a bit more focused on research, it's now, I would say, almost 99% programming. But also a lot of systems engineering. So trying to figure out how to debug like distributed training pipelines and things like this. So the roles in the company are kind of dynamic and they evolve. And right now I'm quite happy being kind of heads down, earphones on, coding all day.
I see. But so what we'll do is, can you give a overview what Hugging, because we all know what Hugging Face does, right? But many of the folks don't know. It's just like, for them, Hugging Face is just a nice emoji. So it would be great that if you can give an overview of what Hugging Face does and its role in basically in generative AI or NLP community, to be very specific.
Yeah, sure. So Hugging Face is an open source company, And I would say our kind of core mission is to lower the barriers of access for machine learning, broadly speaking. And the company has a variety of open source libraries and a platform called the Huggingface Hub, where the community can share models, data sets, and demos for other people to kind of interact and build on top of. And as part of that kind of ecosystem, you get this sort of nice feedback loop where one individual or group of individuals will create, for example, a really great data set, and then other people will train models on that data set, and then those models then feed into people building cool demos or applications with them, and then that kind of loop kind of iterates several times. And I would say in that sense, it's kind of like the traditional like open core type company where you have, I mean, maybe this is the question that you were going to ask next is like, how do you make money? But basically, since all of our software is free and most of the services on the hub are free, the way we generate revenue is primarily through building services that enterprise customers typically want to use. So an example of this is we have something called inference endpoints where people can essentially deploy any model on the hub on their own cloud or on a cloud of their choice. And then we have other things around paid compute for the demos, which we call spaces. And then we have various partnerships on hardware manufacturers trying to kind of build the next generation chips to run transformers, training and inference as efficiently as possible.
I see. Okay. So guys, I think now you know a good overview of what Huggingface does and how they're making money. But okay, so since you brought about this open source thing, right? So I don't know whether you have heard this or not. So back when OpenAI started, so OpenAI said, make the AI open for everyone, like the word said, OpenAI.
Yeah.
And when Huggingface came into the picture, he said, we'll make a very good chatbot for us. And now
that's right.
They're totally you guys are making the AI open source for everyone. And ultimately, OpenAI came up with ChatGPT, which is the chatbot that everyone is looking for, right? So yeah,
exactly. Yes.
That's how funny things are. Okay, so just can you briefly talk about some interesting projects that you guys are doing at Huggingface?
Sure.
Share, yeah, I know.
Yeah. I mean, like all of our stuff is open, so it's pretty easy we don't really have any secrets. I would say at the moment, we have a couple of things I can talk about. So one is at the level of, say, the ecosystem that I find interesting. So essentially, since Meta released Llama and then Llama 2 and Code Llama, we've seen an explosion of models appearing on the hub. So these are typically like fine-tuned versions of the original base models. And I would say one of the most exciting things in this space has been the development of like efficient techniques for fine-tuning. So in the literature, a variety of researchers have developed things like LoRa, which is a special technique called low-rank adaptation, where essentially instead of trying to fine-tune or train all the parameters in these quite large models, you sort of carefully select which layers of the neural network to insert some adapters, which are then, the parameters you actually learn, and everything else is kept frozen. And this, I think, has been a great enabler of the community to be able to train these models on like the single GPU, for example. You can almost fit Llama 65 billion parameters and fine tune it on a single kind of, GPU that you have in your desktop. And this is part of, I think, two main efforts we have. One is called PEFT, which is the parameter efficient fine tuning library. And then inside Transformers itself, we have various integrations with another library called Bits and Bytes by Tim Detmers, which does all this extremely cool quantization methods to basically reduce the memory usage. And I think this has been one of the biggest like impacts we've seen in the LLM community. Is now anyone can essentially train and fine tune their model. And I would say on the other side has been since LLMs and ChatGPT kind of exploded in terms of people wanting to have demos, you now need to have very fast inference. And some of my colleagues at Huggingface have created a library called Text Generation Inference, which is a highly optimized implementation of the kind of most popular transformer architectures. So you can essentially stream tokens and generate text with a similar level of speed as what you see in ChatGPT. And so those things I think have really been the kind of, at least in this year, the kind of core sort of foundation pillars for all the LLM building that's happening around the hub. And then there's a third thing, which is the work I've been doing with colleagues in the research team, is to try and see if we can find a series of like good recipes for doing this reinforcement learning from human feedback. And this is like, the kind of secret sauce behind ChatGPT and the Llama 2 chat models. But a lot of this is kind of not really open knowledge. It's hidden inside papers. And when you take those papers and you try to then replicate them, you find that it doesn't work. And so there's a lot of experimentation needed, especially with the reinforcement learning side of things. And that's the sort of area that I'm personally quite excited about.
Yeah. So this brings to my next question. So we'll talk about two stuff right now that you touched upon. First is the research part. Me being a research engineer, I'm very much interested in research. And the second thing is the RLHF part. I think that has taken the world by surprise when they started applying RL to. Generally, we have seen this RL setup in vision and all, where you try to in robotic system, but all of a sudden RL into NLP and it bursted out the stuff, right? So with respect to research, so how does a common day of a researcher in Huggingface looks like? That's the first question. And what kind of like projects you pick, and what's the ultimate goal right now that Huggingface is having with respect to research?
Yeah, those are great questions. So the way we do research at Huggingface is quite different to the sort of other labs. So at Google and DeepMind and Meta, in most cases, the focus is on doing research in the form of writing papers and pushing the state of the art forward. Whereas a lot of the focus in the research team at Huggingface is more about making things accessible and providing artifacts that can act as kind of a foundation for the other members of the research community to build on. And a really nice example of this is the Big Code collaboration, which my colleague Leandro and Dubna, they run with ServiceNow. And this was an attempt to essentially replicate OpenAI's Codex model. So this was a sort of early code generation model that was kind of powering, Copilot in the early days. And the basic idea there was to say, okay, if we want to train a really good code generation model, we need to have a really good data set. And at the time, there were like a couple of, bits and pieces scattered around the Huggingface hub. And what they did was a large amount of work creating a huge data set of code called the stack, which had some kind of nice features. For example, you could opt out. So if you provided your GitHub handle, you could be removed from the training data, which is kind of great from a governance perspective. And you could also filter through the licenses. So you had essentially like a permissive form of the stack, which is only trained on like Apache and MIT licenses. And then you have the other part, which is all the kind of, restrictive licenses like GPL and also the unlicensed data. And this data set has now provided the foundation for like many follow-up models. So after the sort of star coder models, which they trained, for example, Code Llama used this, various other sort of big LLMs have used parts of this, like the Falcon models. And I think this is kind of primarily what our goal is, and our objective is to do these kind of projects where you're not necessarily doing the paper writing and discovering the foundational new things, but you're trying to take the kind of best practices and then make those available to as many people as possible.
You doing all these jobs makes life like the folks like us very easy to do our jobs. So thank you so much for doing all this, right? I know.
Yeah, I mean, in many ways, it's like the same spirit as like our libraries, right? So like if you think about the Transformers library, it has that kind of ease of use. So like when a new architecture or model comes out, it's very quickly integrated. So you don't have to like, typically look at the original research code, which is often a bit of a mess. And that's kind of the same goal in the research team, is to kind of save this time. And there is a lot of work that goes into this, like, building these data sets and also, finding the right set of like ingredients to train good models. These are all things that often take a lot of computing power. And most of the big companies, they just give you the sort of model and they say, okay, we won't tell you anything about how we trained it. And that's like, I think, a good thing. It's still good that we have models, but it's not great that we don't really know the recipe.
Yeah. True. No, you bringing out stuff openly to the world means a lot to everyone. Like that's how the research is progressing, right? Otherwise, if everyone is keeping their model, it's just like OpenAI, then what other players will do, right, in the market?
Exactly.
Okay, so I just forgot. I had a very good question in my mind, but okay, I'll ask about that. So let's talk about RL, right? So your focus is on RL part, right? I know you have developed a library around that. That's called TRL, I guess. So I have used that
That's
library.
right.
That's a very good library. Abstracts out many things. You just need to plug in some configurations and you're good to go. So what else you are planning to do in this RL area for us, and when you can
yeah
features, right?
Yeah, so one of the things that we sort of realized when we started looking at this was around March, I think, this year, was trying to identify what are the things that are missing from the community perspective. And I would say at that time, it was pretty clear that we were missing good instruction data sets, because this was before Llama, this was before, the world changed. And we also realized that the community was kind of missing, let's say, stable recipes for training like a real application of this RLHF. So a lot of the examples that people have done so far are kind of like toy examples where you use perhaps like a data set like Anthropic's sort of helpful, harmless, honest data set. And this is like the kind of a great way to sort of just get a feeling for what works. But if you want to train something that is like genuinely a good chatbot, then you really want to figure out all the steps of the pipeline. And so another area we've focused on has been collecting the instruction data set and also the data set of human preferences, by having essentially one of our own models interacting with annotators who then rank the kind of preferences or the responses according to which one is better. And the goal at the end of the project is to try and open source as much of all of this as possible. So provide the data sets where we can, all the models and the code, and also a kind of technical, say, handbook, which shares a lot of the things that we learned in the process. And there's a lot of, especially when you do PPO or the reinforcement learning part of this, there's a lot of like hyperparameter tuning, and finding a kind of set of like intuitions for like what you should change is something that we've developed, and we want to share that. And I don't want to give an exact date, but definitely I would say soon we should be able to release all this material.
Okay, awesome. So we are expecting this. At least I'm very excited. I know other folks would be, but yeah, this RL. So do you think RL is the way forward, or we can like at the near future we'll have only instruction fine tuning or full fine tuning will solve the task for us, or do you think RL component is needed to get a better model, very similar to ChatGPT or some more powerful models?
Yeah, it's a fantastic question. And I think I'm still a bit not sure. So I would say I was quite surprised how far instruction tuning brought the field forward. So I think when the Alpaca data set came out, which was this kind of self-instruct approach where you use GPT-3 or GPT-4 to kind of generate data for you, which you train on. I was surprised that worked so well. So these original Llama models were incredibly good. And then since then, the community has done amazing things and very creative things around instruction tuning. For example, there's a group of researchers called the Wizard LM team, and they train really state-of-the-art, like fine-tuned Llama models. And they have a very clever technique where they use kind of evolutionary algorithms to kind of progressively generate a diverse data set of instructions. And all these approaches, I think, they kind of work because there is a very powerful model called GPT-4, and you can kind of distill the knowledge of GPT-4 into these like data sets, which you then learn from. And I think if you want to have a fairly capable chatbot that you train yourself, I think this process really does the job. I think if you look at various benchmarks that have been used for evaluating chatbots, most of these fine-tuned models, they get comparable scores to ChatGPT. But what I think is missing is often this additional factor. So one is around the alignment. So typically you're bounded by how diverse your data set is. So if your instruction data set doesn't contain examples around, let's say, harmlessness or, trying to minimize toxicity, then your resulting model will then typically, do things that you may not want it to do. And when you interact with ChatGPT or Llama 2, you can really see this alignment kick in. So you can talk to the model, and then at some point you say, okay, now I want to, build a bomb at home. And then immediately it says, no, I can't help you with that. And I think that kind of alignment mechanism is something that I think can't really be mimicked through just instruction tuning. And the other one that I think is really interesting and is a big topic right now is the question of hallucinations. So how do you kind of prevent the language model from very confidently telling you basically bullshit? Like, if you ask it a question like, who is Lewis Tunstall, it will give you some made up answer about someone, and it will be very confident that it's correct, and it's just fake. And as far as we know, the sort of best technique that's available for this is like two tricks. One is that you try to incorporate context into the language model. So you try to use a database that you can then query at runtime, and then you use those queries to kind of ground the response. And this is typically called RAG and these other techniques. This works, I think, quite well. But as far as we can tell, like really solving the root cause seems to require some element of human supervision or human preferences, where you have annotators essentially correcting the model and saying, no, that's a sort of hallucination or a confabulation. And so I feel at the moment that so far, I think RL is probably the key thing if you want to really minimize that. And you really see that in a lot of the work that Anthropic has done. So if you look at their Claude 2 technical report, the hallucination factor is really, really down to like the 1 or 2% level. And as far as we know, you never really know, but as far as we know, that was probably achieved through reinforcement learning. So I feel like those are the two things that are kind of key. And a third one that is kind of on my mind at the moment is how do you solve very complex tasks? For example, if you ask many of these chatbots, they say technical questions about physics, they typically fall over and they can't really solve that. And so it is thought that perhaps if you do some like kind of classic reinforcement learning, where you have perhaps an environment where the model is able to use tools, and then you use reinforcement learning to kind of teach it which tools to use and, how to kind of solve complicated answers, it eventually learns this like, multi-step kind of reasoning. And that seems to me to be like potentially another place where we may need reinforcement learning if we want to solve, complex, scientific problems with language models.
Oh, okay. Okay. So like we are in for this RL game for quite a bit now, unless something out of the box comes that helps our model with some human supervision to do all this, right?
Exactly. And to be fair, there is many researchers trying to find alternatives, right? So one major problem with the reinforcement learning technique is it's an algorithm that only really scales with data and size. So it's kind of like a horrible situation where you may not see the capabilities emerge unless you acquire enough data. And that data is typically very expensive because it requires human in the loop interactions. And so there's a lot of very interesting work about trying to bypass part of those issues, and also trying to see, can you just get very, very similar results just through clever adaptations of instruction tuning? And I think, some clever people will find alternatives that work really well.
Just a matter of time, I guess. But yeah, that's how the current situation is. So like what I believe is RL part fixes our model a bit, and it helps us a bit in hallucination as well, right? Now, if you see a general problem with LLMs that we have right now is the model hallucinates like a lot. If you start asking very specific question, they'll give you answer. It seems, wow, the answer is very good. but all of a sudden we found that answer is incorrect, right? So what are your like Hugging Face plans, or what do you think as a person, like as a researcher, that how can we tackle this hallucination problem of LLMs? Because it ultimately affects the production level thing, right? I mean, you cannot put a model that you want to productionize and that hallucinates all of a sudden, and then the
Exactly.
come back to you. Yeah.
Yeah, I think in the short term, probably these retrieval augmented techniques like RAG are probably going to be the most effective, pragmatic way of making progress. So if you have some LLM that's trained as a chatbot, you don't want to have to do another multi-million-dollar project to reduce the hallucinations. And so RAG gives you, I think, a pretty good line of sight to get something that works well in production. But then I think at a sort of deeper level is trying to find out if there are ways we can mitigate the hallucinations that don't necessarily require a large amount of human supervision, because this is still, I think, the bottleneck that the open source community is not being able to kind of overcome. So OpenAI and Anthropic and Google, they're investing millions of dollars in human annotators to kind of guide their model training. And so in the absence of that, probably what we need to do is find methods to mitigate hallucinations, potentially using other LLMs. And there is a very interesting set of papers by Anthropic around techniques called constitutional AI, where you try to essentially do reinforcement learning, but now the model is guiding itself. So it's kind of like a sort of essentially the method works by saying, the model has an initial response, and then the model critiques whether that response is kind of aligned with a set of constitutional principles, and whether those kind of methods can be kind of generalized to mitigate hallucinations. So there you probably need some external knowledge base or something that you can use during the training to sort of say, okay, fact check this result. That might be one way forward, but I think it's still, fairly early days to solve that.
Okay, so we are quite very far. We are quite not there yet with this space, but yeah, I think eventually with multiple companies doing the research, I think we'll solve the problem hallucination a bit. But you bring that point very correctly. RAG does solve it to an extent, but the issue with RAG, what I see is, let's say if you give, because that eats up the context space, right? What do you think right now? Like Llama and all did show that you can go up to a very large context size. So do you think will that improve? Because eventually, like if we keep on increasing context length, I don't think that helps a lot with the results. Ultimately, we are, according to me, the question is like our models are not there yet with respect to the how we are treating the context length there, right?
That's right. And I think, I mean, there's kind of different ways of doing RAG. One is where you do the simple thing, you just take your database and it's like the retriever that gives you some chunks of text that are kind of semantically related to the query. And then the language model just takes that as a context and then generates a response. But if you do, like, let's say the true RAG, what you actually try to do is fine tune the whole system. So you try to fine tune the weights of a language model, and then you typically have some sort of neural retriever. And then you fine tune, like back propagate throughout the whole system. And then you get something which is typically more efficient. So the queries then are like much more aligned with the whole thing. I think that will partially solve the system or the problem of the long context, because if you get very good at like retrieving the relevant context, then it's maybe less of a problem. But indeed, if you want to do very hard things like, I don't know, ask questions about legal contracts or scientific documents or medical documents, these are often very long things, maybe hundreds of pages, and fitting that into your 100K context starts to get a bit of a challenge. And also the inference costs are quite high, right? You're starting to pay a lot of money just to get your answers. So I think we'll see RAG for the next, definitely a few months, maybe years, being like the kind of, let's say, patch job. But for the other part, I think it's just going to require some research and ingenuity from the community.
Okay. Okay.
And one of the codes I had to use was written by a bunch of Polish researchers, and all the code was in Polish. So, like, all the comments, all the variable names, everything. And this was like really, really hard to debug. So I remember using like Google Translate to just copy paste all the code snippets.